So again, gobbled up.
Yeah.
So let's round this out here. We're finishing up, doing some comparisons of radar to sky, and these are the things that you're watching for. So basically you want to know where the updrafts and the downdrafts are at within the storm. The downdrafts are preceded by your shelf clouds, representing outflowing air. Your updrafts are where your inflow is at, and that's what's helping to create the storm. Your updraft region is also where, if you're going to have, in the case of a supercell storm, wall cloud, funnel cloud, tornado rotation, that's the cloud feature you want to be watching for. Your rear flank downdrafts and your forward flank downdrafts, again, are areas that represent downdrafting winds, possibly hail, certainly the rainfall in the forward flank downdraft, maybe or maybe not in the rear flank, depending on whether it's a high precipitation or a classic supercell. So again, keeping in mind that the position relative to the storm is all important. If you're spotting for help, you don't have any choice. You just need to know, as that's approaching you, what part of the storm is going to reach your area, and based on that, what to anticipate. But you're looking for where the air is going up or where the air is coming down. And you want to make sure you want to be in the right position if you're a mobile spotter. And if you're stationary, again, it's just all in how that storm crosses your path. So here we're comparing sky and radar. And you are at position X. And so from the radar perspective, as you can see here, and based on a radar loop and or a warning that was issued on it, the warning will describe the direction and speed at which that storm is moving. If you're out in the field and have no access to radar, hopefully at the minimum that you hear on the radio, the storm that's in your proximity and the direction it's moving. But in this case here, you can see it's moving to the northeast bound. And back here in the hook, this is where your rotation center would be at, this is where your wall cloud would be at, and you'll notice it's off to your west-northwest, and as it moves to the northeast, it's going to be positioned several miles to your north. Now in this position where you're at right now, you're in a rain-free area. So you have a great view of what you want to see off to your west-northwest, which is what's up here in the sky. And as it moves along to the northeast, you're going to remain in a good position. You're going to be in the dry air. You're going to have a good vantage point on this. Now, from the sky perspective, in this picture here, we're essentially looking towards the west. And off here, just to the right of us, to the west-northwest, or you can see here, just to the west-northwest, is the location of the wall cloud. And you can see some clear slotting taking place in here. So this is our focus for where possible tornado development would be. Now, as you're looking at this in the sky, it's going to be coming out of the screen towards you, but also notice because of the radar component that is moving to the northeast, there's also going to be a component of motion towards the right. The problem is with that is that the sky perspective is, I mean, it's literally taken up your entire world. When you're looking at the sky and you're looking at this wall cloud approaching you. So as you see this moving, it's almost going to be looking like it's going to come right over the top of you. But again, in reality, by the time it gets up to your position, it's going to be off your right-hand shoulder a couple miles away. But as you're watching it, you're going to be wondering, is this going to come right over the top of me, or is it going to pass just to my north? And this is where the really good, this is where the experience, I mean, chasers that have been doing this for 10 and 20 years know how to position themselves close enough that they're out of harm's way, but yet they're in a great vantage point like you see here. In this image here, from the radar perspective, you can see the hook echo right here. So this is where your rotation center is at. Notice the direction of motion left to right. So this is going to pass just across to your north as it gets equal to your position. So as you're looking at this in the sky, and again you're looking out due west, this is literally going to be coming straight out of the screen at us. But this feature here, again, that's the location right here in the wall cloud. And it's going to be coming out of the screen at us, but it's going to pass, that lower section here is going to pass just off to your right by maybe a mile or two. Now notice also if you happen to be, say, I don't know, maybe up further up here, where you're in this boundary here, remember what I talked about before, the boundary between the heavy rainfall and the updraft region right in this zone here, potential that what you've seen here may be some pretty large hailstones. And this one here, the radar images are pretty small, but we have, and this is up around Fort Wayne, we have this supercell storm right here. And over here on the right-hand side is the Doppler relative velocity data. Now the radar in this case here, let me get my bearings on this here. I thought I had this figured out. I don't recall, to be honest with you. But there is a counterclockwise rotation that's present within this here, and for some reason I just am not picking that up at the moment. But right in this area, right in there, right out ahead of the hook echo, that's the position of where this person is right here.
Would it be just where that little green spot is?
What's that?
Where the rotation is a little green spot.
It could be right in this location here, but I'm not sure where the radar is at relative to that, and that's the problem I'm having. Oh, that didn't, let me back up on this here. Guess I needed to move my hand onto that and do
Take
this.
a look and listen. Yes. And damage. This is it.
So as you saw there, I mean, they were in the tornado circulation now. On the edge of it, the core of it looked like maybe just a block, the next block over. And that's what is referred to as the bear's cage. I mean, that was awful nasty weather that they just experienced. And to be observing this up on the second floor in your house was really not a very smart thing to do either. But we got some nice, great footage to watch though, huh?
Oh, yeah.
In this one here, you can see the upward spiraling taking place within the wall cloud. I mean, that's very easy to see here. And this is in real time here. Now, there is something going on down here, and I really can't make it out for sure whether that's upward spiraling air associated with the tornado itself, or if it might be somehow rear flank downdraft in here that's causing that. But there's no question there's an upward spiraling taking place here. Now, when you take a look at the radar perspective, you can see the inflow notch is right up here, and this little purple triangle right there is a representation of where this rotation center is at. As you can see, based on the arrow of motion, it's going to pass just to your north of your position. So again, you're in a good spot. You're in the rain fear area right now, and it looks like the worst of it's going to pass off to your north. Looks like you'll probably get clipped a little bit by rear flank downdraft rain back down here, which is off the edge of the picture to the left here. You're looking westbound in the sky here, and again, it's going to be coming out of the screen towards you. And again, it's going to look like it's almost going to hit you here. But again, by watching the radar and knowing that it's got a component of motion to the right, by the time it gets up close to you here, it's going to be even a little bit further north than where it's currently positioned right now. So again, a nice example of a good spotter position related to that storm. Excuse me. In this one here, you can see the tornado up in the top, and you can see the very well-defined hook echo in the bottom there. And you can see this storm is moving left to right. So the hook echo portion here is going to pass off to your north. And so again, as you're looking out west, this is going to again be coming out of the screen towards you, but again pass a mile or so off towards your right. So again, a decent spotter position relative to the storm. So for those of you who are mobile, that's what you want to be shooting for.
On that radar image on the grid there, is there a, do those delineate a certain size or distance?
You know, it very well could, and I'm going to guess it's probably, this being actually out in one of the plain states, those might be mile by mile square grids, would be my guess on that. So that being the case then, it looks like that this feature that's going to be roughly in that position here will pass maybe about 2 miles north of their position.